Hello, welcome to the SPAG video series. In this video, we're going to talk about how to create an ELAN service using HVPLS. And in order to implement HVPLS, we will be using BGP Auto Discovery. And BGP Auto Discovery is used to create a full mesh VPLS. So first of all, talking about HVPLS. HVPLS means hierarchical VPLS. When we say hierarchical, that means that we have two levels, or we have two different types of pseudowires. One is spoke pseudowires. Those are the pseudowires which connect between your access nodes, that is R1, R2, R3, R4, to the edge nodes, which are your ASR 9031, 9032, ASR 9002, and ASR 9001. So when I'm talking about the edge nodes, these are the service provider core network edge nodes. Now, the spoke pseudowires are going to be manual point-to-point pseudowires. The core pseudowires, the pseudowires which are formed between the edge nodes of the core network, so they will be automatically discovered or formed using BGP configurations. There is no manual pseudowire config that you would need. Now, what is the advantage of HVPLS sort of implementation in service provider network? So first of all, let's talk about full mesh VPLS from the access nodes itself. When we need to establish an ELAN service for customers with different locations, let's assume CE1, CE2, CE3, CE4 are customer devices which are in different geographical location. In order to connect them, we need to establish an ELAN service. Now, if we establish a full mesh ELAN service and we start the we configure a full mesh VPLS on the access nodes itself, you will notice that R1 will have three pseudowires, one going to R2, one going to R3, and one going to R4. There are three pseudowires which R1 has to actually establish in order to transport ELAN traffic, ELAN customer traffic from CE1 to all other nodes, CE3, CE4, and CE2, and vice versa. HVPLS is specifically targeted on bringing this pseudowire scalability down on the access nodes. With HVPLS sort of an implementation, looking at the diagram itself, there is only one point-to-point pseudowire that you need to create, that is from R1 to the nearest customer core edge node, that is ASR 9031. So we created just one point-to-point pseudowire when compared to three pseudowires in a full mesh VPLS implementation starting from the access. So that's actually the background on a hierarchical VPLS, which is HVPLS. Now, looking at the configuration, so first of all, talking about BGP, let me get to the CLI here, and this is R1. Sorry, I gotta get to ASR 9031. So let me look at the BGP configuration here real quick. So I'm going to give a run on BGP config. So this is displaying only the BGP config. Router BGP3, this is the autonomous system that I'm using. And I've created a neighbor relationship with all the service provider core network edge devices. That is ASR 9032, 9001, and 9002. And I have defined an additional address family of L2 VPN VPLS. This is to exchange L2 VPN or L2 VPN auto discovery updates with the BGP neighbors. And also do remember that we have two IOSXR based devices, ASR 9001 and ASR 9000, ASR 9000-1 and ASR 9000-2. Those are both ASR 9000 devices. You need to use a prefix length size of 2, which is in order to interoperate with IOSXR devices. And when you are going through the configuration task in the lab guide itself, you will be pointed to the ASR 9K interop white paper, which talks about this interoperability and gives you the configuration also. So you can actually grab the configuration templates from there and then configure your 9031, 9032, ASR 9001 and ASR 9002. So once you have configured the BGP, so you will see that your BGP, show IP BGP summary, you will see that the BGP neighbors are up. I got 3 neighbors, 11.1.1, 11.1.1.2, and 121.0.1.2. Now coming to the auto discovery, right? In order to do auto discovery, I'm going to get into the layer 3 L2 VFI mode. So let me quickly jump to the L2. Okay, so L2 VFI, and when you're mentioning L2 VFI, this is the auto discovery configuration that you need, and the auto discovery configurations are well documented here. So you would need to actually get into the L2 VFI mode and give the name of a VFI. Here, I mean, I have just used it as part 2, and auto discovery is the keyword you need so that you know that this VFI deals with auto discovery of BGP neighbors, and you would have to define a VPN ID. So in my case, I've defined a VPN ID of 200, and then you would associate it with the bridge domain, because you know that you'd be stitching 2 pseudo wires, and you'd be stitching the spoke and then the core pseudo wires. So both of them have to be in the same bridge domain in order to switch packets back and forth. Right. So quickly jumping back into the CLI, you will see that the L2 VFI auto discovery is configured, and you will have the bridge domain. Now the neighbor 122.2.2.2, this is the point-to-point pseudo wire that I create with R1. So the 122.2.2.2 is the loopback address of R1. So I'm creating manual pseudo wire with R1, which is a spoke pseudo wire, and we don't see the code pseudo wires because this is auto discovery and they're automatically created. Now let's actually jump onto ASR 9K. I'm going to do a show run L2 VPN, and I have a lot of configs here, so I'm going to just jump to the relevant config. So this is the relevant config where we are implementing BGP auto discovery, and I have the configuration. I'm creating a bridge group and a bridge domain of part 2. Again, the neighbor 122.3.3.2 pseudo wire ID. This is the spoke pseudo wire or the manual pseudo wire that I'm creating with the access node R3. And this is the auto discovery config, by the way. VFI part 2, VPN ID 200. Remember, it should be the same VPN ID. So the VPN ID here on ASR 9K, which was 200, and the VPN ID here should match. Otherwise, your the neighbors will not come up. We just mentioned what is auto discovery protocol we need to use, auto discovery BGP, and then the route target, route distinguisher, and then the signaling protocol would be your LDP. So you will have all these configurations mentioned here, so you need to configure accordingly. So once that is configured, I'm going to take a quick peek on whether my pseudo wires are established, right? So the command is show MPLS L2 transport VC, and the VPN ID that we used here was 200, so I'm going to use 200 and then detail. So let me first look at the summary and then we'll get to the detail, or I'm going to just say 200. So you will see that there are actually 3 pseudo wires already established. So 11.1.1, 11.1.1.2, and 121.0.1.2. These, okay, these are the auto discovery neighbors. These are the auto discovery BGP auto discovery neighbors, and then we have configured pseudo wires with all these BGP neighbors. So now we have established the VPLS auto discovery between all the core network edge devices. Now, since if I look back into the configuration, I've created a manual pseudo wire with R1, right, the spoke pseudo wire. So I'm going to quickly take a look at the spoke pseudo wire. I've given it a different VCID, which is 1000. So I'm going to just do VCID 1000, and you will see that the VCID 1000 is up too. So we have all the pseudo wires established. In the meantime, I'm going to look at the ASR 9K as well. I'm going to just do a show L2 VPN and bridge domain and then a BD name, and BD name that was part 2, and then detail part 2. I'm not going to do detail. So you will see that the 3 pseudo wires are up, and these are the core pseudo wires. And let's look at the spoke pseudo wire. The spoke pseudo wire is also here. You don't have to give another command to verify that. The spoke pseudo wire is also up. Now what I'm going to do is quickly, I have all my ELAN completely configured. Now C1 can reach C2, C4, C3. And now I'm going to just do a quick ping between C1 and C3, right? This is my C3, and this is my C1. I'm sorry. So now what I'm going to do is I'm going to just do a quick ping. So between C1 and C2, so 2.2.2.2 is the C1. Like if I give a show run interface VLAN 100, I have 1.1.2, sorry, that's pinged 2.1.1.2. So you'll see that the ping is successful, and then even here, if I do a ping 2.1.1.18, 18 is the IP address of CE13. Let's do a show run interface VLAN 100. You'll see the ping is successful. So this is essentially how you create ELAN services using HVPLS. So again, going back, quickly summarizing what we did, we created a BGP auto discovery. We created a BGP configuration. We created BGP configuration between the core edge devices, which is 9031, 9032, 9001, 9002. We established a full mesh VPLS, and this was auto discovered using BGP. And then we created a manual point-to-point pseudo wire between R1 and ASR 903, and vice versa between the access devices and then the customer edge nodes, customer service provider core edge nodes. So we put them, we stitched the pseudo wire, we put it in the same bridge domain, and once we did all the configurations, we checked the forwarding between the customer devices C1, C2, C3, and C4. So I hope the HVPLS lab was useful. Enjoy configuring ELAN services using HVPLS, and thanks for looking at the SPAG videos.